Let's jump in. Okay, so this was one of the worksheets. I submitted another set of worksheets for you, um, plus the answers on Canvas. I didn't put the names in though. I think I'm going to do yet another version of that and have names as well. So there'd be kind of three worksheets. One is a blank one with just the problem of looking something like this. And then the next one will be the answers with structures. And then the third one will be structures and names. That way you'll have all parts together. Okay, so let's look at these. These are kind of some typical reactions. I'm going to go through them all. Let's see, where are we here? Yeah. Okay. So here we have alcohol and acid, acidic environment, and we get a low yield ester. So acid backbone, alcohol backbone. So this is one, 1, 2, 3, 4. Okay, so we've got propanol, 1, 2, 3, 4. 3-methyl butanoic acid. And then for the ester, we've got propyl, naming the so we name the alcohol part for naming of ester, so that's propyl. And we've got a 4-carbon acid part of the ester with a methyl branch. So we've got propyl 3-methyl butanoate. Now this is the part is the ester naming part, and also the O8's name if we have a uh, ion from the acids. Okay, so we have 1, 2, 3, 4, and we've got. Okay, so we have an ester in an alkaline environment. It means we're going to saponify it. So we've got a 4-carbon acid salt, and we have the sodium that goes with it. And then plus the ethanol. Oops. Okay, so let's name it. Okay, we've got ethyl. So this is going to be ethanol. This is going to be sodium butanoate. Okay, so jump in if you have any questions now. All right, so we've got an acid in a basic or alkaline environment. That means it's going to be deprotonated. So we've got a 1, 2, 3, 4, 4 carbon acid. So that's going to be butanoic acid. And we are going to get sometimes you'll see the charge up here. Sometimes you don't. So okay, so we have phenol here. And if you remember from unit 1, actually, um, phenol is a very weak acid in a basic environment. So this is going to be phenol. This is an H. Okay, so we have an organic acid in an acidic environment, and there's no change. And this again is butanoic acid. Okay, then we have just an organic acid in water. And what's going to happen is going to also, the water is going to be able to pull off the proton as well. Okay, now here we have a phosphoric acid ester. So what's happening is the phosphoric acid is forming an ester with the OH group on carbon number 6. Now, theoretically, it can form on any of the carbons with an OH. Carbon number 6 is the least sterically favorable. In other words, it's got the most clearance around it. And then sometimes it bonds with carbon number 4, sometimes carbon number 1. In this case, it's 6. So what happens is, and this is the alcohol part of the ester as well. So phosphorus is a triprotic acid, meaning there are 3 OH groups on it that can form an ester with an alcohol. Okay, now this happens to be the first step in glycolysis is forming a carbon 6 phosphoric acid ester. And then the next step is forming it's called bis, meaning 2, phosphoric ester. So there's be 2 phosphates, esters formed on that glucose. Okay, anyway, that's for later glycolysis. Okay, so what happens in a so first of all, we have esters. Secondly, we have a basic alkaline environment. That means saponification occurs. Okay, that means these guys, these esters are both broken apart. So we've got the original alcohol plus the other alcohol, which in this case is ethanol. So this is glucose. Ethanol plus the acid salt. Okay, so this is going to be sodium phosphate. Now, I could also say trisodium phosphate, but they don't usually say that. They usually say sodium phosphate. I like trisodium phosphate personally. Okay, so that looks complicated because of the glucose, but it's really, glucose is just acting as an alcohol. Okay, so this ester here can be made 3 ways, and you need to note the best and the least yields. Okay, so let's go with the best yield first. So it's going to be best, least. Okay, the best one is going to be, first of all, we've got 4 carbon acid part, and we have 2 carbon alcohol part. Okay, so the best one's going to be with the acid chloride. The medium one is going to be the anhydride. And then the least is going to be with the acid itself. Two ways to make that ester. Okay, so we're going to name this butyl chloride. This will be butyl anhydride. And that's going to be butanoic acid. And these, of course, were all ethanol. To name this ester is going to be ethyl. Butanoate. Okay. This will be on the test. Okay, so here we have an ester under acidic conditions. What happens under acidic?
Professor,
Yeah.
can you go back to what's going to be on the test so I can write it down real fast?
Oh, to be able to synthesize an ester 3 different ways and know which gives the best yield, which gives the least yield. So it's this guy here. This here.
Okay.
Do you need more time?
5 seconds. All right, I got it. Thank you.
Okay. All right, so we have an ester here. It is a 1, 2, 3, 4. So it's another ethyl butanate. And what happens in an acidic environment, what's going to happen is you're going to end up with the acid part. So this is the acid part here, alcohol part. Okay, so the acid is butanoic acid, and it's protonated because it's an acidic environment, plus the alcohol part. Okay, so this is going to be ethyl butanoate. This is going to be butanoic acid. This is going to be ethanol. Okay, and this is, the next one is the acid chloride with ethanol. I'm going to end up forming an ester. And it's 1, 2, 3, 4 again. Okay, so we need to name this. So this is going to be 3-methyl, excuse me, um, butyl chloride, ethanol. And here we have ethyl. And then we have hydrochloric acid. Okay, here we have the anhydride. Remember, anhydrides are just two esters in one molecule. So here's one ester, and here is the other ester. So what happens is it bonds with the alcohol and kicks off the other part of the ester in the acidic form. So that is a 3-carbon acid. So that's, well, enoic acid. And this is a 1, 2, 3. Two methyl propanol. And this would be dipropyl anhydride. Frequently, if the each side is the same, frequently they don't say dipropyl, they'll just say propyl anhydride. I like to put the di there because it's consistent with everything else we've been doing. So that's optional. If you want to just put propyl anhydride, that's fine. Okay, so we're going to make an ester from this. So the alcohol part's going to be the yellow there. Okay, so it's going to be 2-methyl propyl propanoate. Now this here is I've been having a real phlegmy voice lately, so it's definitely lower pitched than normal. Okay, this particular molecule is called choline. It's one of the ones on the list to know. This is a neurotransmitter. It's a very important one. It's a very common neurotransmitter. And what happens is in synapse chemistry, to fire the nerve, it sends a neurotransmitter across the synapse gap, and this is one of them. And then the receptor on the other end. There's an enzyme that then pulls this neurotransmitter off the receptor. Now, there's a whole class of pesticides called cholinesterase inhibitors. And what happens is the enzyme that pulls the neurotransmitter off the receptor is inhibited. So the nerve only fires once and is dead after that, basically. Very common pesticides, and they're called organophosphate pesticides. Bad, bad stuff. Okay, anyway, choline. Now, we haven't talked much at all about nitrogens. Nitrogens have three bonds. Notice this has four bonds, hence it's got to have a positive charge. Okay, so nitrogen with four bonds, positive charge. And this is called an ammonium ion. Okay, notice it's a two carbon backbone, and this will form the alcohol part. This will be the acid part. Okay, so this is a three carbon acid, so that's propanoic acid. This is choline. And what's going to happen is um, that's going to be the ester part. So let's draw the acid on the left. Then we have choline up here. So you don't have to name this ester that forms. Now, choline is used, you'll see choline a lot in biochemical molecules, a lot. For example, the common emulsifier lecithin found in egg yolks includes choline. In fact, that's one of the triglycerides you need to know is lecithin. I'm going to go over that and possibly today for sure by Wednesday. Okay, so anyway, this is a simple acid alcohol ester formation. So this is the ester over here. Okay. Okay, so how do we get this guy here? Now, if you remember, this comes from phenol. Because even though phenol is an alcohol, it functions as a weak acid because the benzene ring acts to stabilize this anion over here, or the conjugate base, if you remember from 305. Okay. Okay, so the sodium hydroxide, sodium hydroxide is the one that pulls off that hydrogen. Okay, and then this was going to be sodium benzoate. Okay. All right, I'm going to do this one over here because I need more room. So we're talking about choline, which we just saw up here. That's what choline looks like. Plus what equals lecithin. Okay, so let me draw lecithin over here. This would be any 18 carbon um, long acidic part. Same with this over here. Okay, so this is choline. Phosphate acid. This is the glycol backbone. Okay, so to make this, let's do this here. Okay, so to make this, over here I said make it with choline and something else. So here's choline. And then we're going to need a three carbon backbone. Okay. All right, so we've got the acid here. This is functioning as the alcohol. And here we have the ester here. And actually, it's a diester because this is also an ester here. And you could call this on the left here an acid, maybe an acid ester, since this ester this is also an ester here. And this would be the acid part. Okay, that's kind of a tricky one. Any questions about that one? Okay. Okay, and this one here, I wanted you to tell me how you make this wax. Now, remember a wax, it's got a really long acid and a long alcohol. Now, this can be C14, C20, C30, same with the alcohol side. So let's just go with C14, but it doesn't really matter. You just choose one. This is going to be 14 long. This would be the acid. And this would be the alcohol here, and this is going to be C29. But again, you can make it as long or short as you want. As long as it's no shorter than, C14 is a little short for a wax, but anyway, just 20, 30, whatever. Let's make it 29. That's what I want here. Just a big, long ester. Okay, these are all the answers. Okay, draw structures for the following. Now let's see, we have I didn't give you much room to work on here. Of course, I didn't do these. A colleague of mine did these. I would have given you more room. Okay, so let's look at this here. First of all, it is a acid, and the acid is 6 carbons with a branch on 3 and 2. Okay, so 1, 2, 3 is methyl, 2 is bromo. I'm going to draw them over here to get more space. Okay, so number 2 is propyl benzoic acid. Okay, so this is benzoic acid. And a branch on carbon number 4. So that'd be 1, 2, 3. Number 4. Okay, we have sodium and an OH. Okay. So this is a deprotonated acid, of benzoic acid. So we have 4 carbon acid. So that's 1, 2, 3, 4. And at carbon number 2, we have a methyl group. Okay, we have 3 carbon ethyl OH, so that's an ester. So 1, 2, 3. And number 3 is potassium ethanoate. So potassium ethanoate. F is 2 carbons. Right, potassium ethanoate, and then methyl ethanoate. So methyl ethanoate is an ester. So this is the ethanoate from the ethanoic acid, and this would be a methyl. I usually put a dot here too on the end, just so know it's a completed. And then number 7 is name these. Okay, so this is an acid. It is a 1, 2, 3, 4 carbon acid. So that would be 1, 2, 3, 4 phenyl. Or phenyl butanoic acid. Okay, this is going to be, sometimes, usually it's written like this. So we have 1, 2, 3, 4 again. So this is going to be a 1, 2, 3. I don't know. A sodium 3-bromopropanoate. Okay, here we have a ester, number 9. Okay, so this is the alcohol end, which is a methyl. And this is a 1, 2, 3. Carbon acid. So this is going to be methyl. It's a 1 carbon alcohol. 2 methyl is here. Propanoate. Okay, here we've got a ester again. So here we're looking at a this is the alcohol, 2 carbon alcohol, and a benzoate. So we're looking at a ethyl di. Oops, give me myself more room. So this is a 3,5 dichlorobenzo. So it's a 2-carbon alcohol, and this is based on benzoic acid. All right. More reactions. Okay, so we've got a 1, 2, 3 acid and a um, 1-carbon alcohol. And let's do this over here. Okay, so we have the alcohol and the acid. So 3-carbon acid. The branch on carbon number 2. And the alcohol part is going to be um, this is kind of strange. Um, let's modify this to a 2-carbon because this just doesn't happen in nature here. So this is going to be like okay, so the alcohol is going to be a 2-carbon alcohol with a branch on carbon number 2. So it's going to be 2-phenyl ethyl, 3-carbon with a branch on number 2, 2-methyl, oops, 3-carbon, not 2. So this is the backbone right there. Okay, so number 13, we've got an acid chloride. Plus an alcohol. Okay, so those two together are going to give us an ester. And this is a 3-carbon. So this over here is going to be propionic acid. Um, 2-methyl propanoic acid. And we need to name this. So this is going to be 2-phenyl ethanol. Okay, so we have the acid chloride, 3-carbon acid chloride, so it's going to be 2-methyl propyl chloride. This is going to be phenol. So this is going to be the alcohol. So we've got okay, so it's going to be phenol. It's the alcohol part. 2-methyl propanoate. Okay, so here we have an ester. Basic environment, that means it's going to be saponified. So this is a 1, 2, 3, 4-carbon. Or carbon acid. Two carbon alcohol. Okay, so under saponification, we generate the alcohol, which is ethanol. And the acid's salt. So we've got 4 carbons with a branch at carbon number 2. So to name this is going to be 2-methyl 2-methyl butanoate, and it's sodium. And then lastly, we have 2 more. Okay, so we have an ester again in an acidic environment. In this case, we're going to generate, now this is a phenol, and it's a 1, 2, 3 carbon acid. So to name this, we're going to say phenol. and it's going to be a 2-methyl. Okay, so it's going to generate the acid because we're in an acidic environment. Phenol, and this is a 2-methyl. Propanoic acid. We have one up here. Okay, we have acid and then phenol. Okay, phenol is acting as the alcohol. So we're going to have 3-carbon acid. So this will be phenol, propanoate. Okay, and here are the answers. Okay, so I haven't really covered much of lipids today. Excuse me. So what do you guys think? Okay, where did we start? We started right here, I think. Yeah. Now, on Wednesday, I want to go over some of the more complex acids and lipids, which will start here. I also included a multiple choice worksheet. And I included the answers, but I want to go over the how the answers were derived as well. Okay. Okay, exams next week. Um, Andrea, are you okay? Do I need to go over those again? Oh, you got it. Okay. Okay, so we'll be doing this again, and I did want to point out going over to Where is, what happened to, oh, no. Okay, we'll go down to files, at three worksheets. Um, I added this worksheet as well. Um, well, a little review from Unit 2. Um, like this one, for example, this is from Unit 1. This is from Unit 2, Unit 1, Unit 1. So this is why we're not going to have a final in here because every test is a final, except for test 1. Okay, and then I also put down the um, I did an answer sheet. These would be the answers. And I'm going to put another one of these, same sheet, and I'm going to put in names as well. So we have 3 of these, one blank one. Okay, this guy here is, okay, here's the multiple choice I just referenced with answers. And there also is the lipid part with answers. And here's the worksheet that um, it didn't go over this one. This is a different one. Um, Another one with answers. This is the one I want to work today. Okay, so you've got all the worksheets. And again, I'm going to add this Unit 3 worksheet, answers plus names as well. I'll try to get those done today. All right. How are you guys doing? Do you guys think this unit is harder than Unit 2? Or Unit 2 is harder? Of course, you're not done studying yet for Unit 3, but about the same. I was thinking they were about the same also. Possibly um, uh, Unit 3 might be a tiny bit harder because of the structures, but Unit 2 had a lot of structures too. So, Okay, all right. Well, I guess I'll see Monday